I'm Professor Chris Binns. I'm Professor of Nanoscience here at the Department of Physics and Astronomy at the University of Leicester. The project that we're working on here is to develop a new type of solar cell material which we're doing in collaboration with a Norwegian company called Ensol AS. The difference between this new technology and the solar panels that exist up to now are manifold. One is that it's a thin film coated technology, so it can be literally sprayed onto things. So anything can be converted into a power generating surface. It is also transparent, which means it can even be put onto windows. So for example, buildings and windows could become power generators. In principle, it could also be more efficient than existing technologies. The University of Leicester is involved in the project because the group here working on nanoscience are experts in the production of metal nanoparticles, and these are the active components in the new solar cell material. So already we had a lot of expertise in producing the right kind of material for Ensol, but with a small amount of investment we've actually modified the kit a bit, and now we'll be able to produce the entire solar cell. This new technology can be used in a wide range of applications, including industrial and domestic. For example, in the domestic market, you can imagine it being coated onto roof tiles, so you could buy roof tiles ready coated to produce solar power. Also windows. But in industrial applications, for example, offices could be coated with this new material, or at least the office windows. All it would do is produce a slight tinting on the windows, which you might find an advantage, in fact. So your windows become solar power generators in industrial plants. It could be used in transport. For example, it could be coated onto aeroplane wings. There was this new highlight recently in the press about this solar-powered plane. This kind of technology would be perfect for that, because the films that we're producing to produce the power are incredibly thin, just a few nanometers thick, much thinner than the width of a human hair, and would be incredibly light. Well, in the UK, the amount of raw solar energy falling onto the surface averages at 500 watts per square metre, and that's averaged over all our dull weather. Even in dull weather, you've got to remember that actually there's still quite a lot of light of the right frequency falling onto a surface. Now, the efficiency of these, we're hoping for at least 20%. So you're talking about 100 watts per square metre, that kind of power capacity. But if you look at a typical building with its, thousands of square meters of panels available for pointing at the sun, you can see that there's power to burn. Well, the most exciting part of this research for me is the fact that we're using nanoparticles, which we studied for years for loads of things, finding a use in something that could be an important technology.